All right, so we'll pick up from there on solving those. So the key is getting the variable by itself, doing the opposite operations until the variable's by itself. If it's not by itself, you're not done. Let's go to one similar to that. Let's say we had 3x minus 7 equals 10x plus 14. So this one's got variables in two different places and plain numbers in two different places. So we're going to have to end up getting all the variables to one side and all the numbers to the other. And it doesn't matter which one you start with. I usually start with the things that are not variables first and get rid of those. So like on this left side, you know, we got the 3x and we got a minus 7. How could I get rid of the minus 7? Yeah, add it to the 14. We add it to the 14 because the 14 and their 7 are what? What are they called? Like terms. 14's a plain number, 7's a plain number, so they're like terms, so you put them together. And now I've got 3x on one side, and on the other side I've got two things. I got a 10x and a 21. I need to get all the x's to one side. Well, I've already got all the numbers to the right-hand side over here with, you know, the 21. So I need to move this 10 over here with the 3x. How do I move that 10? Yeah, why am I subtracting it? It was positive. It's not necessarily that it's the addition sign here with the 21, but it's that it's a positive 10x. So we're going to subtract it to get it over here. That's negative 7x is equal to 21. And then last step would be what? Division. Good, Chris. Divide by negative 7. And then that would be what? Negative 3. Good job. So one step at a time. I'm okay if you're comfortable with this and you want to do more than one step at a time, do it. It's fine. I'm trying to do one step at a time as I'm explaining, just so that we don't get, you know, lost in it if we get sidetracked a little bit. So if you want to do more than one step, that's absolutely fine with me. In fact, I encourage it. All right, let's look at this one. Let's say we had 3 parentheses, 2x minus 4 is equal to 7 minus parentheses x plus 5. A little bit more difficult one. Stepping it up as we go here. What do we see on both sides of this problem? Parentheses. And parentheses should indicate that we need to do what? Distributive property. Good. So on the left side, the only thing there to distribute is a 3. So I'm going to distribute 3 to both of those pieces, which multiply 3 times 2x, get 6x, 3 times negative 4 be negative 12. What gets distributed on the right side? It is negative 1. Good. There's nothing written there, but there's like an imaginary negative 1 sitting there. That 7 is hanging out in the front. It's 7 minus all of that. So it's really a negative 1 that we're distributing to both of those pieces. So that would be 7 minus x minus 5. And I usually like to simplify each side if possible before I start moving things from one side to the other. So the left side doesn't simplify any. But the right-hand side, we got a 7 and a minus 5. You know, those two are like terms. So 7 minus 5 would be 2. And then it's a shorter problem. Then there's a little less stuff to worry about from there. Does it matter on the right side, the equal sign, you have negative x plus 2 or the cube? It does not. No, it doesn't matter at all. Whichever way you want to put that. If you had negative x plus 2, that's the same thing as 2 minus x. So I'm fine with it either way. And then go ahead, Terrence. All right, so let's back up to the distributed property step. Is that where you're, okay, just go back up all the way up there. All right, so we're going back up to here. All right, so on the left side, you're good up to, tell me when to stop. Right there. All right. Since there was nothing in front of the parentheses except for this minus sign right here, that minus sign is going to tell us, oh, okay, there's really a -1 that's there. Okay, it's a understood 1 in front of it. Anytime there's nothing written there, it's a 1. Okay, and we're going to distribute -1 to both of these pieces. So -1 times x is -1x, and then -1 times 5 is -5. And the 7 is just hanging out waiting for stuff to happen. Okay. Then the next thing that we did is we looked at it and said, okay, well, this 7 and this -5, they're both numbers, plain numbers. So we could put them together because they're like terms. So 7 minus 5 is 2. And then we still have the minus x or -1x. You with me now? All right, good. And then the other side stayed the same. All right. From there, we want to get all the x's to one side and all the numbers to the other. And it doesn't matter which way you go. I'm gonna move the x's to the left. I generally like to keep my variables on the left-hand side. I'm not sure why that is. Maybe it's just the way that I've always done it, or maybe it's because I'm left-handed. I'm not sure. So, you can move the 12 by addition because it was subtraction on the left side. So to move it, you got to add. So anytime you're crossing the equal sign, it's the opposite operation. So that gives us 6x plus 4, or equals 14 minus x. Or as Ms. King was saying, you could have -x plus 14 there if you wanted to. Be the same thing. And then, how would we get that x over there with the 6x? Yeah, very good. Add 1x. And that's going to give us 7x equal 14. One last step. And x is equal to 2. Now, if you'll notice, all my equal signs are in a straight line. That will help you stay organized if you can do it that way, because it's kind of, when I teach younger students, I usually make them draw a line down the middle of the page so that they know that there's the left side of the equation and the right side of the equation. And in order to cross that line, you have to do the opposite operation. But that helps you. Maybe that's a trick that you want to employ there. That line, everything has to change to cross it. Let's look at another one. Let's throw a few fractions in there because everybody loves fractions. 2/3 minus 1/2 x equals 7/3. This one's not a bad one with fractions. It's actually pretty, pretty nice to us on this one with the fractions because they don't have to find a common denominator. So this one, we're trying to get x by itself again. So I see this 2/3 doesn't have an x, so it needs to move over there with the 7/3. So it's a positive 2/3. So I'm going to use a negative 2/3 to get rid of it and move it over there. Those cancel out. That leaves us -1/2 x equals 5/3. Because when you subtract fractions, 7 minus 2, and the denominator stays the same. If for chance you're not comfortable doing that, the calculator's your friend. You can do 7/3 minus 2/3. And if the calculator gives you back that in a decimal, change it to a fraction by pressing math, enter, enter. And that gets you the fraction back. And that works with the 83s or the 84s. Okay. And so that's where the 5/3. Now, how do we get rid of the negative 1/2 in front of the x? What's going on between the 1/2 and the x? They're multiplying. So the opposite of that would be dividing. So we want to divide by the negative 1/2. And dividing by a fraction is the same thing as multiplying by its reciprocal, which means flip it over and multiply. So if you did that, that's 5/3 times negative 2/1. All right. And then multiply straight across. 5 times 2, 10, 3, it's negative. If you're going to do that in the calculator, if you want to just do the straight division in the calculator, you've got to be very careful with fractions when you're doing division. You need to put them in parentheses. So like 5/3 divided by parentheses negative 1/2. And then math, enter. And there's the negative 10 over. If you don't put them in parentheses, it will not work them correctly. It'll do the division left to right, which is not what you want to happen. Okay, so be very careful. If you're going to do fractions in your calculator, you need to put them in parentheses to use that. So be careful of that. All right. Let us do another one with some fractions in it. Not that every problem you're going to see is going to have fractions in it, but I think these are the... we don't need the lights. It's okay. Lights went out over here. That's okay. Let's say we had 2/5 x plus 4/5 minus 1/3 x equals 7/8. So this one has multiple denominators and two things that have an x on the same side. Okay. If x's are on the same side, we just want to combine them using the signs that are already there. So we want 2/5 minus 1/3. We're not doing the opposite on that because we're not moving across that wall that we've got. We're not crossing the wall, so we don't change signs. Okay, so we're on the same side. So 2/5 minus 1/3. And I'm just going to do that here. And then math, enter. With addition and subtraction, you don't have to use parentheses with fractions in the calculator. Only with division do you have to do that. So 1/15. So that's 1 over. So when I combine these two, that's 1/15 x plus 4/5 is equal to 7/8. So I'm just combining the like terms on the left side to get that done. Okay. The next thing to do would be get x by itself. So what needs to move? Yeah, the 4/5. Good. How do I move it? All right. Subtraction would be the right way because they're adding it. So the opposite of that is subtraction. That's going to cancel on that side. 1/15x is equal to whatever 7/8 minus 4/5 is, and I want to put that in fraction form. 3/40. So again, I'm not doing a whole lot of work here to get common denominators. I'm not overly concerned whether you can do that or not. You've got a calculator that's used it to get things done. Now, how do I get x by itself now? Yes, that's right. Divide both sides by 1/15. And again, parentheses are your friend when you're dividing fractions. Math, enter. 9/8. So don't forget, when you put this in the calculator, do parentheses. That will save you a major hassle out of that. Okay. All right. Let's get away from fractions for a minute and do just a longer problem that doesn't have fractions in it. H. -2 parentheses x plus 4 close parentheses plus 3x is equal to x minus 8. So we've got a lot of x's in this problem, but we got to think, okay, order of operations is still math, so that means I've got to go where first? Parentheses. And those parentheses in an equation usually tell us to do what? Distributive property. So we're going to distribute -2 to everything in the parentheses there. So that'd be -2 times x, be -2x, -2 times 4, be -8. Everything else is the same. Now, this is not a always kind of rule, but it is something that I try to do on every problem just to make things easier for me. And that's combine like terms on the same side before I start moving stuff across. So here I have a -2x and a +3x there. The same, they're like terms. So I'm going to put those together first. So -2x and +3x would be how much? 1x, good. And the -8 is still there. And then we get something interesting happening here. What do we notice about both sides of the equation? They're exactly the same. That means something pretty special when that happens. When both sides of the equation are exactly the same, and that means, oh, okay, if I move this x over here, what happens to them? Yeah, they come to 0. They cancel each other out. And it ends up being -8 is equal to -8. Is -8 equal to -8? Is that true? If there's -$8 in my checking account today, and then tomorrow there's -$8 in my checking account, that's the same amount of money, or lack thereof. Okay, so that's always true. If that statement right there, all the variables have canceled out, and you get two numbers left, and they're equal to each other, and it's true, then what that's called is it's called an identity. That's what that's called. What it means is that the answers are all real numbers. That means I could pick any number that's a real number and put it in for x in that original equation, and it's an answer for it. It works. Okay? Anytime all the variables cancel out and this statement right here is true, then that means it's an identity and the answers are all real numbers. Okay? So tie those together. Identity, all real numbers. They go together. Okay? All right, let's look at another one. We can get something else going on here. 3 parentheses 3x minus 1 is equal to 9x plus 7. What's the first step on this problem? Distributive property. I'm multiplying 3 out. So 3 times 3x, 3 times minus 1. That'd be 9x minus 3 is equal to 9x plus 7. Well, this one, they're not exactly the same on each side. It's a little bit different. So if I try to move the 9x over here, 9x minus 9x, they cancel each other out again. But I'm left with negative 3 is equal to 7. Is negative 3 ever equal to 7? No, never is. So that's a false statement. Anytime all the variables cancel out and you're left with a false statement, then that's called a contradiction. It really means that there's no solution. Or, here's, the empty set symbol. Those would all be acceptable answers for that. Contradiction means there's no solution. That empty set symbol, the circle with the slash through it, or the empty brackets, they're all mean the same thing. But that only happens if all the variables cancel out and you're left with a false statement. Okay? So you're still doing all the same steps as far as solving the equation. You're just going to see all the variables canceling out for it to be either a identity, all real numbers, or a contradiction where there's no solution. So you got to look for those sort of things. All right. Those are the exceptional types of problems that you might encounter when you're just solving equations. Most of the time, you're going to get an answer, x equals 5, something like that, like what most of our examples had, where x equals a number. That's what's going to happen most of the time. But these two things do happen some, just not much. Any questions about just solving regular equations? All right, next little set of things here in the same section is we're going to solve literal equations. What that means is solve for a certain variable. Okay. So this is what I'm talking about. We're going to have an equation. Maybe it's something like this. 3x plus y equals 7. And we want to solve for y. Okay. So we've got two different variables here. We want to get one of them by itself. So it's the same skills. We're just not going to get an answer that says y equals 4 or some sort of number. We're going to get an equation as an answer. That's what the literal equation part means. Okay, so if y is what we're trying to get by itself, what part of that problem is not a y? The 3x. On that side with the y, the 3x is not a y. So I want to get rid of it. How do I get rid of it? Yeah. These cancel out, and there's y left over. And then on the right-hand side, this is where I don't care which way you write it. I'm going to write it like this, negative 3x plus 7. I'm writing it that way because I know where we're headed later today, and we need to be able to write it in that order. Or, it's just as correct to be written this way in this particular section. 7 minus 3x. I wouldn't count off either way there. Understand that, on your exams, they're multiple choice, so you may have this as an option. You might have this as an option. You won't have both of those as an option because you can only have one correct answer on those tests. So it can be written either of those ways and still be correct. Out of that. That was pretty easy though. It's a one stepper. Do something a little bit more difficult here. That is the answer. That equation, y equals negative 3x plus 7. That's the difference in the literal equations and the ones that we just got through doing. Is the fact that you're not going to get a single number answer. You're going to get an equation left. A lot of other stuff there. So let's look at this one. Say we had 5x plus 4y equals negative 16, and we want to solve for y again. A little bit more involvement here with this one because there's a number in front of the y. So again, you're going to start with the idea, okay, what variable am I trying to get by itself, trying to get the y by itself, and what's not a y? The 5x. So we need to get rid of it. How do we get rid of it? That's right. Subtract it to take it to the right. That gets us 4y negative 5x minus 16 in this case. And then y is not completely by itself yet. So I got to get rid of that 4. How do I get rid of that 4? That's correct. Divide every piece by 4. So if I divide the left side by 4, that means I got to divide the entire right side by 4. So I'm going to divide each individual piece by 4. Whatever you do to one piece of the equation, you got to do that, you do the whole equation that way. There's y. And then over here, negative 5 is not divisible by 4. It doesn't go into it evenly. So I'm going to leave that as a fraction. Negative 5 over 4. But does 4 go into 16? Yeah, 4 times. So it reduces. That being my answer. Now, I'm going to show you a few alternative answers to this that are correct, but they're written differently. One of them is, just changing the order. That's also correct. But the one that can throw you, that you might end up seeing, is one where you have the negative 5x minus 16, and then they draw it like that. And they don't divide it. They don't divide them individually. This is also correct. This is what I like. That to me, that's the best answer. But understand that these others are also correct answers because they did the same work. It's just in a different order that they've written the answer there. But that go ahead.
How likely is it that besides the one that you said is the way you would write it, the other two would be on it?
The likelihood of this top one here being there is higher when none of the numbers divide evenly. Like, if you had 5x minus 13, it's very likely that it'll be written that way because 4 won't go into either of them. The reason that it's more likely to be the way that I put the star beside here is because 4 did go into one of those. Usually when one of them is divisible by the number you're dividing by, they'll write it this way. If it's not divisible, they'll write it that way a lot of times.
So when it's written that way, if you go look at the step you did before you get the final answer, it's pretty much dead.
Exactly. It will always be that way. Yes, that's right. That's right. The step we did right here where we divided by 4, that's exactly what that will look like. So if you divide it by 3, it'd be a something over 3. That's what it's going to look like. So recognizing equivalent answers can be maybe a little bit of a hurdle to jump here, but like Paula said, whatever you did the last step, you should be able to see that in the answer. That's what's going to happen there. Let's get to these here that don't even have any numbers in them. I love these. V is equal to L W H. We want to solve for, let's do W. So volume is equal to length times width times height is what that formula is there. And we want to solve that formula for W. So what's going on between the L, the W, and the H? They're all being multiplied together. Anytime they're mashed together like that, they're all being multiplied. The only thing we want to leave on that side is W. So what do we need to divide by to leave W? What'd you say? Length and height. Yes, we can divide by both of those at the same time. Length and height. I'm going to divide by length and height. I don't know why I did cursive L there, or H there. Not. And these will cancel, leaving W. And then we get volume divided by length times height. And we've got that equation solved. There's nothing else to do. The ones without numbers, I sometimes think are easier than the ones with numbers. There's less simplifying. You can't simplify V, L, and H. They don't do much. All right, let's look at this one. P is equal to 2 parentheses L plus W. We're going to solve for, let's solve for L. Solve for the length on this. This is the perimeter formula for a rectangle. Perimeter is equal to 2 times the length plus the width. So, several different ways to attack this problem. What would your guys' first step be? Okay, that's a great idea. Distribute the 2, since it's 2L plus 2W on that side. That works perfectly. What would be the next step? Remember, we're trying to get L by itself. That's what we're going for. Very good. That gets the things that are not L's away from the L's. So that's just going to be P minus 2W is equal to 2L. We're almost there. Divide by 2. So if I divide that whole side by 2, or each individual thing by 2. So I could have P minus 2W over 2 written that way. Or I could have the P over 2 minus, what happens here if I do it that way? What happens to those two tubes? Yeah, it's just minus W. Either of those would be considered correct. It's more likely that this one is the correct answer because we had something that simplified, something that the 2 divided into something. So it's more likely that the one on the right is the one that's there. But understand that the one on the left is just as correct as the one on the right as well. Usually if something will divide into it, that's when they will throw that, they'll go ahead and divide out of that. All right, so we've solved regular equations, just straight up, get an x by itself kind of stuff. We've talked about identities and contradictions. We've solved literal equations, getting just a variable by itself in there. The next section is where we're taking this stuff and doing some application with it. So we're going to do a couple of word problems. I'm not going to, overload you with word problems at all. So we're just going to do a couple of them and try to apply some of this stuff. So the perimeter, I'm just going to write out this word problem. And the perimeter of a rectangular case is 40 inches. The length of the case is is 5 inches more than the width. I don't know why I didn't skip on there. Our job is to find the length and width of the case. All right. So, not incredibly difficult word problem. You could kind of guess your way around in it and find the answers here. Just by thinking, okay, well, it's 40 inches. There's only certain numbers that add up to be 40 and stuff. But I'm going to show you how to do it with an equation. And the key is finding the clues that they tell you about, so you know which formulas to use. The perimeter tells us that, hey, it's a perimeter of a rectangular case. So I know that the perimeter formula is, I don't ever remember it that way. I do this. That's the one I remember. 2 times length plus 2 times W. That's what perimeter of a rectangle is to me. Okay. And then they give us some information about the length being 5 inches long more than the width, or 5 inches longer than the width. So the length would be whatever the width is plus 5. That's what this line tells us that. That's what that line tells us. So I'm just breaking down this word problem. And so that means that I can take all this information that the perimeter is 40 inches. So that means I can replace the perimeter P with 40. And that the length is W plus 5. So that means I can replace the length with W plus 5. And I can solve this equation using the skills that I just talked about in section 1. Okay. So I've set up this equation to make it easy to solve. So what's my first step to do this equation here? Yeah, good. Distribute the 2. And then what? Okay, 2W and 2W be 4W. That's awesome. Good. 30 equal to 4W divided by 4. So W is going to be 30 divided by 4. And when we're in the context of a word problem, we usually will go ahead and just get a decimal out of that. 7.5. So the width is 7.5 inches. So that means the length would be how much? Yeah, 12.5. 5 more than that. 5 plus 7 would be 12.5 inches. And we could check that. We know the perimeter should be 40. So if I add, 12.5 and 12.5, that's 25. And then I add 7.5 and 7.5, that's 15. 25 and 15 does add up to be 40. So those are the correct 2 numbers there. So setting up that equation there is pretty key to doing that. And I'll kind of emphasize, make sure you put a star by that example. Hey, there's probably something like that on the exam type thing. And on the exams, it's a 2-hour time limit, but it's open book, open note. I want you to understand that. So don't think you can't use your notes and things on your exams online. I mean, you're at home taking them, so use your book, use your notes to help you. All these examples can help you too. Okay, let's do another one. This one, I don't know if you remember doing these problems, maybe in high school math or something, but distance equals rate times time. Or the formula we use, D equals RT is what we usually use for that. So we'll need that for this one. Now this one's a little bit of a stretch on this, but it's a good problem to work with. I like doing this problem. Okay. Bill and Ted are traveling on an excellent adventure. The trip takes 2 hours for Bill. And 2.5 hours for Ted. Ted lives 40 miles farther away than Bill. That's why it takes him longer. Okay. Ted travels 5 miles per hour faster than Bill. Find each person's average speed. Okay. All right. So, interesting problem here. This is kind of like, those problems that you hear people say, oh, 2 trains left, the same station going in opposite directions. How long before they're 40 miles apart? Something like that. This is kind of that problem. But we're talking about Bill and Ted. They're traveling to the same place. Ted is traveling 40 miles further than Bill, but he's going 5 miles an hour faster. Okay. So one of the best ways to approach one of these problems and to organize yourself, and this is one of the things that maybe if I'd had this when I was in high school, way to organize my thoughts, I would have been better at word problems than I was then. You got Bill and you got Ted. So I'm going to make a little chart here. And I know I'm dealing with distance, rate, and time. D equals RT. I know that because it talked about a distance. It talked about how fast somebody was traveling and the time, that it takes 2 hours and 2.5 hours out of that. So I'm going to have a column for the rate, a column for the time, and a column for the distance for each one of these guys. Okay. So I know that Ted is traveling 5 miles an hour faster than Bill. So Bill's going the slowest. So I'm going to call Bill's rate X. And if Bill's rate is X and Ted is traveling 5 miles an hour faster, that would be X plus 5 for Ted. Right? That makes sense? Now, we know how much time each one of them took. Bill took how long? Bill took 2 hours. Ted took how long? 2.5 hours. Okay. Now, distance is supposed to equal rate times time, correct? So that'd be 2x, and this would be 2.5 times x plus 5. So I'm taking those And I'm going to use that equation. Now, here's what we got to keep in mind. What do we know about Ted's distance? That Ted, he was 40 miles farther than Bill. So that was taking whatever Bill drove, and we added 40 to it. Right? So the distance for Ted, 2.5 times x plus 5. And the distance for Bill, 2x. But remember, to equal Ted's distance, you got to add 40. Okay. So maybe highlighting helps here. Bill, Ted, that sort of thing. So that's where I'm getting that stuff from, because we're both ending up in the same spot. So that's why we're equal, right? Now I've got just an equation that if I can find an x, that's going to tell me how fast Bill was going. And if I know how fast Bill was going, I just add 5 and I got how fast Ted was going. Okay. So I just need to solve this equation. What's my first step in solving that equation? Distributive property. So 2.5 times x and 2.5 times 5. Be 10. Half of 5 is 2.5, so 12.5. And I've got a decimal in there because I had a decimal in the original problem, so that's all right. And then 2x plus 40 is still over here. Now what? That's a good idea. So 2.5x now is equal to 2x plus 27.5. Is that what that is? With a calculator, check me there. 40. 12, yeah. Yeah, that's what it is. All right. Now what? It's a little easier. $2.50 minus $2. 50 cents. And then last step. $27.5 divided by 0.5. 55 miles per hour. For who's that for? Bill or Ted? Bill is the one that was back in our chart there. Bill is the one that's represented by plain X. So that means Ted was going how fast? Ted travels 5 miles an hour faster than Bill, so that would be 60 mph for Ted. Now that was a pretty complex setup for a problem. I don't think you'll encounter anything that complex to set up, but a very, very, that to get that kind of equation, that's almost what you have to set up there. But once you get the equation, y'all didn't have any trouble solving it. Now the word problem part of it is a little bit tough, but like I said, I'm not going to overload you on word problems at all. Not doing a ton of those. You're likely not to see a bunch of those on the test at all. Maybe 1 or 2 on the exam for this stuff. Okay, so more likely to see the perimeter type problem than you are the Bill and Ted Excellent Adventure problem. Like this. Yeah, word problems are a tough thing. Anybody ever seen that movie, Bill and Ted's Excellent Adventure? I was wondering if anybody caught that. That's where I always get that from. They had a bogus adventure and a excellent adventure. I think there was a third one, but yeah. Keanu Reeves' first big movies. All right. So that's our deal with equations. Let's move into the next section. So section 3 of 5 already, and it's not even 10 o'clock yet, or it's right at 10 o'clock, right at it. So section 1.7, we're going to be solving inequalities. Okay, so you're going to hear a lot of the same stuff. We're going to be doing some graphing on number lines and things with this. And I'm going to show you how I want that done and how you need to be able to do both. You know, it's going to use that interval notation that we talked about last Tuesday and some of that stuff. So we're going to kind of maybe go a little further with inequalities than you did maybe in a high school math class and do a little bit of interval notation with our answers. But as far as solving them goes, much the same thing as the equation. So it shouldn't be, much more difficult as far as the solving goes. All right. So let's look at 3x plus 7 is greater than 13. Okay. The greater than symbol there. And still the name of the game is get the variable by itself. It's nothing different as far as that goes. There are a few things we'll need to remember as we go here, but because it's inequalities, we've got to do certain things. But it's still the same steps. You're going to get x by itself, so we're going to subtract 7. There's 3x. And then 13 minus 7 is 6. And then the last step would be what? Divide by 3. The only thing that's different about inequalities is if you divide or multiply by a negative, then you have to flip your symbol around. Okay? So we didn't do that on this one, so we don't flip the symbol. But the only, that's something that you got to encounter. You're going to encounter the next example we do that with. But if you multiply or divide by a negative at any point in the problem, you have to flip the inequality symbol around. So keep that in mind. All right, so here we have the answer to our inequality is x is greater than 2. So we want to write that in set notation. So that's the curly brace. X such that x is greater than 2. That's the easy one. It just copies the answer. All right. And then we want to go into interval notation. And actually also a number line graph. And I like to do the interval and the number line kind of together because I think it makes the interval notation really make a little bit more sense. And with the number line, I'm not real picky about this. You're going to have a picture of the number line on the exams and things. On the labs, you'll actually have to graph them. You have to draw them and stuff. But I'm not real picky about it. I just like, put a couple of numbers on either side of the number that's the answer. So 2 is the number in question here. I'm going to put 0, 1, 2 in the middle, 3, and 4 on the outsides. So that number that it is in the middle. Now, that inequality says x's are greater than 2. Okay, so that means which direction on the number line are we going to go from the 2 for our answers? To the right or to the left of it? So here's 2. Which numbers are greater than 2? To the right, 3 and 4. Okay. So the way we're going to do that is we're going to put a parenthesis on the 2, and then we're going to kind of shade that line that way. Like I just, I'm trying to draw above it there so that we see that all the answers are that direction. We use a parenthesis there because the 2 is not included, because the inequality is a regular greater than sign. If it were an equal to sign, if it had the little bar underneath it, then we're going to use a bracket. The interval notation is parenthesis 2 to infinity. Okay, so you have set notation, you have interval notation, and then you have the graph that goes with it. And I like to do the interval and the graph together just to get us a little better understanding of interval notation. I know in my high school, we tend to not use the parenthesis there, and you may have seen it used like with an open circle and then the shading. That's how we've done it there for years. But I'm trying to make the transition over to doing it this way because I think it makes more sense for you when you go to college math classes, because this is how every college class I've ever taken does it, is with the parentheses and the brackets. Okay, so we're going to try to get our answers that way. All right, let's look at another example. Negative 3x, bless you, plus 5 is greater than or equal to negative 7. Very similar problem, not much different, just a little bit different. What's our first step? Okay. It gives us negative 3x is greater than or equal to negative 12. And then, what's the next step? Divide by negative 3. Now, here's where, because it's an inequality, we've got to be careful. When we divide by a negative, we've got to do what? Flip the sign. So that's going to turn it around to x is less than or equal to, and then negative 12 divided by negative 3 be positive 4. Don't forget your sign rules. You know, negative divided by negative is a positive. All right. And then set notation x such that x is less than or equal to 4. That's the easy one. Interval. Anybody want to take a stab at interval? Okay. What would it go to? Negative infinity. Now here's what I'm going to do. I'm going to turn that around, because negative infinity comes before 4. So the 4 would be the last thing that you would write. You'd write it like that. Negative infinity up to 4, because you read it left to right.
Can you explain one more time why you use
The bracket and not...
Yeah.
The bracket is only used when it's got an equal to mark. It means that the 4 is included in the answer set. A parenthesis means it's not included. That's the difference in a square bracket and a parenthesis in interval notation. So when we draw that on the number line, we would put a bracket and then go to the left. Like that. The bracket means it's included and it goes that direction. Parenthesis would be not included. So if you see an equal to mark on your inequalities, you got to know, oh, I'm using a bracket somewhere in my interval notation here. And you want to remember your interval notation is based off of reading it left to right. Reading the number line left to right. That's why I kind of tend to do those together. Or divide by a negative number. Yeah. That's when you're going to flip your inequality symbol. A little bit more complicated inequality here, depending on how we work it, whether we'll have to flip the symbol or not. So what would y'all pick for your first step? Yeah, that's what I'm the same way. I would subtract the 4 or the 2x, whichever one first. It doesn't matter which. That's going to give me negative 3x less than or equal to 3 plus 2x. And then I need to get the x's together, right? I want to subtract 2x. And notice I hadn't flipped the symbol here because I've not multiplied or divided by anything. I've moved some negative stuff around, but I haven't multiplied or divided by it. So that's why I haven't flipped it. Okay, so then that'll give me negative 5x is less than or equal to 3. And the last step for this one, good, divide by the negative 5. And there I divided by a negative, so that means I have to do what? Flip that symbol, negative 3/5. So then your set notation, the x such that x is greater than or equal to negative 3/5. You might want to take a stab at the interval notation. Very good. That's right. I'm going to have the bracket, but is it going to come first or last? You tell me. Think about the inequality symbol. It's x is greater than negative 3/5. So if it's bigger than negative 3/5, it's going to go toward what? Yeah, it's going to go to the right. So that means that the infinity is going to be on the right. So your negative 3/5 is going to go first, and infinity on the right, positive infinity on the right. So that means on our number line. Now what I've done here on my number line is I put the negative 3/5 there in the middle, and then instead of having to guesstimate where a space is on my number line, all I've done is worked with the numerator, and I did -3, -2, -1 because that's how the negative side works. It goes backwards. And then on the right hand side or the left hand side there, I get -4, and then this is really -5/5, just -1. So I'm just changing the numerator on my fractions, and that gets me my number line built. Like I said, on the exams, you're going to have one already drawn for you, and you're going to see the interval notation or the set notation, and then it'll have a graph drawn with it. And so it'll already have all that stuff spaced out for you. But I'm just kind of showing you how I would do the number line there. And then we're going to put a bracket, moving to the right. And one of the things there, if you've got your variable on the left, like we've got here, notice which direction that's pointing on the inequality symbol. It's pointing to the right. As long as the variable's on the left, that's kind of a shortcut. for you. That it's pointing toward the right, so you know that your graph is going to color toward the right there. Okay. Right. So let's try to do another. Let's do a compound inequality, one that's got kind of stuff mashed together here. -2 is less than 5 plus 3x, and it's less than 20. So this is what's called a compound inequality. All it basically means is you got to get x by itself in the middle. That's all it means. It's just like solving two of them at the same time. Okay. So if I'm trying to get this x by itself in the middle of the problem, I need to move everything that's not an x out of the middle of the problem. So what do I need to get rid of that's in the middle there? All right, how do I get rid of it? Okay, so if I subtract 5 from the middle, I've got to subtract it everywhere else too. So I've got to subtract 5 on the end down here and subtract 5 on that end on the right side as well. So that's going to get me -7 on this side. 3x is left in the middle. And then 20 minus 5 be 15 on that side. And then I'm looking to get x by itself. So one more step. Yeah, divide everybody by 3 and reduce if possible. Okay, so -7/3 doesn't reduce. I don't flip my symbol because I didn't divide by a negative, so I'm just leaving it like that. And then 15 divided by 3 does work out to be 5. So that's nice. So set notation, x, as long as x is between 7/3 and 5. The interval notation, I think, is easier on these because you've got 2 endpoints. It tells you that it starts at 7/3 and goes to 5. But does it use parentheses or brackets? Well, is there an equal to mark on the symbols here? No. So it'd be parentheses, yeah, not brackets on that. Okay. So I think the interval is easier on these compound ones than it is on the others because you know it's in order there. So you just got your endpoints and you put your parentheses or brackets around it depending on what the inequality symbols are. And then when you go to the number line, it's also easy. Now with these, since it's a mix of a fraction and a not fraction, I usually, I just go, okay, I'm gonna make sure I got 5 in there. And I want to get somewhere close, I'm going to estimate. So I know where 5 is. It's right there. So I'm going to put a parenthesis there. And then -7/3 is -6 or is -2 and 1/3, right? 3 goes into 7 2 times with 1 left over. So that's a little bit past -2. That's about right there, maybe. So I put my parentheses and then I just fill in the middle. That's where my shade. My answers are all those numbers in between there. So you can just kind of get an estimate in between there when it's mixed with a fraction and a not. I'll save you a little headache on the number lines. Let's do another compound. 16 is less than or equal to 2x minus 4 is less than 18. And that's on purpose. Equal to mark on the left one, not on the right one. Oh. First step. Get rid of the 4. How? That's going to be 4 or 20. Okay. 2. Now what? Divide all of them by 2. Well, this one's nice because everything is divisible by 2. It'd be 10 and 11. That's easy peasy. What's the interval for this one? What's the interval notation for this one? You know it's going to go from 10 to 11. What gets a bracket and what gets a parenthesis? Yeah, 10 gets a bracket because it's got the equal to mark. So that's why he gets a bracket. Or her. I'm not sure what a 10 is. It's him or her. And 11 doesn't have an equal to mark. So it gets a parenthesis. And then on the number line, 10 to 11. So all of those numbers in between, starting at 10, going up to 11, but not including 11. They don't get much more difficult than those compound ones there in this particular section of inequalities. All right. 3 out of 5. We're done with that one. Let's go to the next section. Now we're going to do a little bit more. We're going to do some graphing in this section. So I'm going to show you graphing it by hand, and then also graphing with the graphing calculator can be helpful with this section as well. So I'm going to show you that, and then we're going to talk about writing some equations and finding some parts of those throughout this section, and in the last section it's about the same thing. So I'm going to swap to some graph paper for a second, and maybe for this section, and then we'll like I said, it's not a incredibly necessary thing. We can still, if you don't have graph paper, you're not going to drown on this. It's not too bad. Okay, so this is section 2.4. So we're jumping out of, been in chapter 1, the first 3 sections. We're going to jump into a couple of sections out of chapter 2 here, and then we'll be out of here for today. Should be plenty early. All right, so linear functions is what this is called. Linear functions are linear equations, basically. In somewhere in high school math, you learned about this type of equation: y equals mx plus b, where m represented the slope of the line and b represented the y-intercept, or where the line crossed the y-axis. Okay, so that was a linear equation. X and y were the variables that were involved in the section 1 where we were solving those literal equations. I had to solve for y a lot because that's what we're going to do in these 2 sections. We're going to solve for y a lot. Okay, so that's why I had to do that. And the difference in linear equations and linear functions is just notation. Remember that y and f of x are exactly the same thing. So you will see them written in that style quite often. for this section. F of x is equal to mx plus b. That just means y equals mx plus b. It's the same thing. Slope, still the y-intercept. Not anything changing as far as that goes. So we want to do a few things with this. We want to graph the equation or graph the function. State the slope, the y-intercept, the domain, and range. Several things. So we're going to go back, talk about domain and range a little bit like we did on Tuesday. The great thing about the linear functions is that the domain and range is very simple because it's linear functions. Linear functions are pretty simple. They don't get quite as complex as some rational functions and some of the other functions that we'll deal with in either Math 100 or 110. So they're very simple. So the domain and range shouldn't be a big deal for us. So the first example we're going to look at is fairly simple equation. F of x is equal to negative 2x plus 6. Okay. And we want to ID the slope and, abbreviate that M. And then the y-intercept, and I'll abbreviate it y-int. Remember, that's the B part of the problem. And then we're going to do the domain and the range. Now, the domain, all of these, the first three things there, slope, y-intercept, and domain, we can do before we even graph it because we know those things. We know the domain. We talked about that on Tuesday. What are the red flags that we look for in domain? You might remember there were two things that had to be in the problem, or one of two things had to be in the problem for us to have something happening to our domain. Yeah, if there was a fraction with an x in the denominator, an x in the bottom. There are no fractions with x's in the bottom in this problem, so that red flag is out. What was the other red flag? Do you remember? Had to be a certain thing in the problem.
An x on the inside of the square root.
An x on the inside of a square root. Well, there's no square roots in these problems. So what's that tell us about the domain for a linear function? It's all real numbers. It's always going to be that. So the domain is the easiest part here because it's always going to be from negative infinity to positive infinity for a linear function. Okay. Now, we're not going to mess with the range until we graph it, and we'll see what's going on there with the range. But what about the slope? What's the slope of this line? Negative 2. What's the y-intercept? Positive 6. All right. So now I'm going to graph it on the coordinate plane. So I'm going to draw myself a little coordinate plane over here. And if you don't have graph paper, make sure you kind of, whoops, draw it better than I did. And, mark off your x and y axis evenly so that it looks fairly close. Okay. Now, the first point that you want to graph when you're graphing linear functions, instead of making a table, like by plugging in x values and working that out, it's a lot more work than we really have to do. What we want to do is start with the y-intercept. So the y-intercept is 6. So I'm gonna put that point down first. So there's 6 on the y-axis. That's what a y-intercept means. It means go to the y-axis, at that number, put a dot. Okay. And then the slope is negative 2. And when you count slope, you want to think of it as rise over run. So we want to think of our slope as a fraction. So how do I write negative 2 as a fraction? Yeah, negative 2 over 1. So rise goes up and down, run goes left to right. Okay? So if we count it as rise over run, rise is negative 2 and the run is 1. So we would go down 2 for the negative 2 and over 1. And then put a dot. Then I could go down 2 from that dot and right 1. And that gets me another dot. I could do that forever if I wanted to. 3 of it's enough. 3 dots is plenty to get a good graph. Sure. So I'm starting at my y-intercept, and I've put that dot there. And then my rise over run, my slope was negative 2. So I'm thinking about that as a fraction. So that's negative 2 over 1. So the negative on the top, the negative 2 makes me go down 2. Down 2. And then the 1 on the bottom is my run. So I'm always going to go to the right 1, whatever the number on the bottom is. We'll do a couple of these where you'll see a different slope, and on the rise and the run will be different. To think about it as a fraction. So because I want my slope to be a fraction, so that I can say, okay, the rise is the top part, the run is the bottom part. Okay, sometimes the slope's already a fraction. This one was negative 2, so we had to think, okay, negative 2 is really negative 2 over 1. So I think rise over run. Okay, so I went down 2, right 1. And that got me the next spot. And then from that dot, I went down to right 1 again, just to get another dot to draw my line with, just so it's a little bit more clear. Okay. Now, the range for that, remember range goes up and down. So what would the range of that graph that we've drawn be? Well, it's got arrows in both directions, right? So this arrow up here is pointing up, and this arrow down here is pointing down. So, and that means it keeps going in both directions forever. So our range is going to be from negative infinity to positive infinity as well. Should be that every time with a linear function.
If you have the positive infinity on the left, right, would that be wrong?
Yes. Yeah. That'd technically be wrong. Bottom to top. Is that like domain is read from left to right?
Right.
Domain or range should be read from bottom to top.
Okay.
You start with
the y-axis, everything on the left, the top and bottom is all negative, and on the right side, top and bottom.
Yes.
If you were trying to read that.
Yes.
Okay.
All right. Let's look at another one and do the same things for it on a different function. And I think it'll start, the rise over run will start clearing up a little bit as we do a few of these here. So let's say we had g of x, same thing as y, is 3/4 x minus 5. Okay. Again, we're going to say the slope, the y-intercept, the domain, which we should know, and the range, which we actually should know as well now. What would the slope of this line be? 3/4. The y-intercept, -5. The domain, yeah, that's right. Negative infinity to positive infinity. Always going to be that. Okay. The range is also that. Okay. If it's in slope-intercept form, which is what these equations are in, if it's in this form, then the domain and range are going to be that. Okay. We're going to see some that are not in this form that the domain and ranges may change some. But as far as if it's in this y equals mx plus b form, that's the domain and range. It's always going to be that. Okay. Now, draw it on the graph, and then I'll show you on the calculator how you can get it to graph one, just so you can check yourself and make sure you graphed it correctly. What's the first dot that I should put on here? -5. Where at? On the bottom, on the y-axis. Yeah. 1, 2, 3, 4, 5. That first dot goes there. Now, my slope is 3 over 4. So it's a 3/4. So my rise is how much? In what direction? It's positive 3. So I'm going to go up 3 and then right 4. Up 3, right 4. Put a dot. Rise 3, run 4. I go up 3 because it's positive, and I go to the right 4 because that's the run. Okay? Then I can go up 3, right 4 one more time to get a third dot. So there we have y equals, or g of x is 3/4 x minus 5. Okay. Now, I want to make sure that I drew that correctly. So I'm going to, on my graphing calculator, I'm going to graph that. So the way that you graph lines on your graphing calculator, press the y equals button, which is up here in the top left. And I've already got an equation in there. I'm going to clear that out. And you just type in the equation. So I want 3/4 x. So I'm going to go 3 divided by 4 x. And the x, remember, is right beside the alpha button. And then minus 5. So minus 5. It should, and then I'm going to hit graph. And it should come up. And that looks a lot like what I drew. So I think I did it correctly. Yes, exactly the same way on the 83. All right. So we've graphed one on the calculator. We've graphed a couple on the paper. Let's look at this next problem and see what's different about it from the others. All right. Slope, y-intercept, domain, and range. But this one has f of x is equal to -3, and that's it. Nothing else in the problem. Just f of x is equal to -3. So there's not an x term in there. So that means that the slope is not there. So the slope is going to be 0 because it's not there. But the y-intercept is there because that plain number is there. So we have y is equal to -3. So -3 is our y-intercept. Now, this one has a domain that's still the same. Negative infinity to positive infinity. The range is not the same. Anytime it's f of x equals a plain number, then the range is different. The slope is 0. The domain is still negative infinity to positive infinity. So what we want to do here is I want to show you what this graph looks like. Y equals -3. The y-intercept is at -3, but the slope is 0. So how much is your rise if your slope is 0? It's 0. So you go up none. And I could write 0 as 0 over 1, right? So if I go up 0 and over 1, I end up just going to the, horizontal. So that blue line is the graph of f of x is equal to -3. So if it's y equals a number or f of x equals a number, then it is a horizontal line at that number. Okay, that's one thing you need to memorize that fact. That if it's y equals a number or f of x equals a number, the graph is just a horizontal line at that number on the y-axis. Okay, the range is just that number. As you think about the range of your y values, what's the y value all the way across this line? It's -3 in every spot. So the range is the y values. Well, the y value is the same all the way across that line. It's -3 the whole time. But the domain is still from -infinity all the way to +infinity. It doesn't, that hadn't changed on this one. So y equals a number or f of x equals a number, same thing. It's a horizontal line at that number. Okay? The domain of -infinity to +infinity, and a range at whatever number that is. So if it's f of x is equal to -3, it's this picture. If it's f of x is equal to 5, then the range is going to be the 5. And notice I've got brackets around that range because that's the only number that it is, and it's included. Okay. All right. Now that can be graphed on your calculator as well. I mean, you can go to y equals and just type in y1, do -3 and hit graph, and it'll show you that horizontal line. Anytime you got y equals or f of x equals, you can graph it on your graphing calculator. It'll do that. If you can type it in, it can graph it. Now, the next one, x equals 4. Is there a problem? This one's a little bit more, a little different. I'm just going to kind of talk you through it. All right. It doesn't have a y. It's just plain old x equals -4. Okay. So when you're looking at one like this, let me go ahead and draw the graph here. It tells us that x is equal to 4. So I know that spot is on the graph. The slope, well, there's not a slope there. I mean, you don't have y equals mx plus b. You don't have that structure in the problem. So the slope is what we call undefined. There's no y-intercept. Okay. The domain is just the number that x is equal to. Here's what happens. If you have an undefined slope, an undefined slope is a vertical line. Okay. So here we have the domain being 4 on that. Okay. So we got 4. That's what x was equal to. The domain is just that. So everywhere on this blue line, x is 4. But everywhere, the y values, though, they're going from +infinity, from -infinity up to +infinity. So the range is that. Okay. X equals a number is a vertical line. X equals a number is going to be a vertical line. It's got what we call undefined slope, means vertical line. Anytime you see undefined slope, you're talking about a vertical line. Anytime you see x equals a number, you're talking about a vertical line on the graph. Domain is going to be whatever that number is, because that's what says x is always equal to 4 for this problem. The range, however, is from -infinity to +infinity. Okay, so it's y equals a number is horizontal. X equals a number is vertical. That's what you got to keep in mind. Keep those things memorized. That way they don't sneak up and get you from time to time. Okay. All right. Not too bad there. Let's look at another problem. Example E. Let's say we had 3x minus 7y is equal to 14. And we want to do the same things that we did with the last 4 examples. with this one. What's wrong with this equation? Y is not by itself. Can we get Y by itself? We talked about that in last section in section 1, getting Y by itself. So let's solve this equation for Y, because it sure makes graphing them a lot easier. Okay, so what would be our first step? Good. Just subtracting 3x. That gets us negative 7y. And I'm going to write it like this, negative 3x plus 14. Now what? Divide all three parts by negative 7. And this is one of those things where you do want to divide individually when you're trying to get an equation ready to graph. You don't want to do that negative 3x plus 14 over a big fraction bar with a negative 7 in the bottom. You want to go ahead and divide them all. All right, and then simplify as much as you can. So left side is just y. The right side, we got a negative 3 divided by a negative 7. What happens to that? Yeah, so it turns it to a positive 3/7 x. And then positive 14 divided by negative 7 would be negative 2. So now we've got this equation in slope-intercept form. And that's the form we want it in. That's what that's called there. So we can tell what the slope is, the y-intercept. And then because it's in slope-intercept form and we have a slope and we have a y-intercept, we know that the domain would be from negative infinity to positive infinity. And we know that the range would be the same thing. Because it's in that form, we get that stuff for free. Okay. Now, what's the slope of this line? 3/7. What's the y-intercept? Negative 2. All right, so I'm ready to graph that then. First dot would be where? Negative 2 on the y-axis. Good. Okay. From there, what do I do? Up 3 over to the right 7. Then I'm going up 3, right 7. Barely got it in there. Absolutely. Good. Great. You could actually do that. Go down 3 and left 7, and to get you the point on the line as well. If you ran out of room, that's a great idea. So you could do down 3, 1, 2, 3, 4, 5, 6, 7. Notice how that dot falls right in line with those other 3. So doing the opposite in both directions gets you the same points on the line. Gets points on the same line. So that's a great idea. And there's our line based on that particular equation. Now, let's do one more similar to that, and then we'll get to the next thing. We're actually doing some slopes of lines based on points. Let's do 10x plus 30y is equal to 0. Do all of the same things for this particular problem as we've been doing. What's our first step? Good job. I'm gonna put that plus 0 out there because I think it may help us. I know it doesn't have to be there because adding 0 to something doesn't change it, but remember we're going for slope intercept form here, so having that plus 0 out on the end is going to help us when we go to do that. What's the next step? Divide by 30. And then reduce. That's negative 1/3. And then 0 divided by anything, still 0. So that helps us a little bit in the fact that we still got to tell what the slope is, the y-intercept, and then domain and range. Which domain and range are both what? Yeah, negative and infinity to positive infinity. What's the y-intercept for this one? 0. And the slope? Negative 1/3. Okay. So that makes this one not too bad to graph here. Plane. Going to 0, which is right there at the origin. And then which direction? Down 1, right 3. Could go up 1, left 3 as well. I'm just thinking about that. What if you didn't have room kind of idea. And if you're unsure of yourself on the calculator, you can go straight to that. Go to negative 1/3 x, and you put plus 0 if you want to. And there's that line. Looks a lot like what I drew there. Okay. Nice little easy way of checking yourself with that graphing calculator. That's what it's useful for. All right. Now, still in the same section. We hadn't quite moved on to the last one yet. But we're going to, instead of graphing lines, what we're going to start doing is building the pieces that we need to be able to take ordered pairs and build a line from. So that first piece, the biggest hurdle that we have to jump is finding that slope. Okay, so let's talk about slope of a line. And slope of a line is the change in y divided by the change in x. Okay. In some math textbooks, I know in this particular textbook, you'll see this symbol. That's the Greek letter delta. Just looks like a triangle. Delta y over delta x. That just means change in y over change in x. We've been talking about slope as being rise over run. Rise is changing in the y direction, right? Because you're going up or down. Run was changing in the x direction because you're moving right or left out of that. So that's where that's coming from. It all still comes down to, it's m, it's the slope. The thing we're going to be working on in this section is if you're given two ordered pairs, x1, y1, and x2, y2, the slope formula is y2 minus y1 over x2 minus x1. That is muy importante. Okay, it's very important that you recognize that formula, be able to use it. We're going to be using it quite a bit in the rest of this section and the next section that we go to. So that's a very important formula. Not that you have to memorize it, because remember, on your exams for this course, you're going to get to use those your notes and things. On the final that we will take on paper, I'll give you, there'll be formulas on your answer document that you'll get to use and stuff. So I'm not going to, let you use it all through the course and then say, hey, can't use it on the final. That's not fair. So you will have formulas on your answer document for your final for this course. So that'll be going on. All right, so we're going to take this formula and we're going to, in the rest of this section, just work on finding the slope of a line between 2 points. And then in the next section, we'll start taking that and building points on there. So let's find the slope. That's the name of our game we're playing right now. So find the slope. Example G. -4, 8, and 2, -3. Those are our two ordered pairs. That's the given ordered pairs out of that. So what we're going to use is that slope formula. And if you'll write it as many times as I do today, you'll have it. You won't even have to look at it, when you go to do your labs or your practice. I promise. All right. So it doesn't matter which point you call the 1 point or the 2 point. It doesn't matter. Just pick one to start with. And the key you got to do here is when you plug that in, you got to make sure, okay, if I'm going to start with the y value of -3, then on the bottom, I have to start with the x value of 2. That ordered pair that I pick has to match up vertically. They're not fractions. They're just, they've got to match up that way. So if I say -3 is the first y value, then I'm going to subtract 8 from it. And then that means on the bottom, I've got 2 minus -4. And then all I'm doing is working that out and simplifying the fraction that I get. So -3 minus 8 would be -11. And then 2 minus -4 would be 6. And that doesn't reduce. So I'm done. I found the slope between those 2 points. In the next section, we're going to do something with that. But right now, that's what we're doing. Just finding that slope. All right. So 10, -6, and 5, +2. So again, I'm going to use this slope formula. Plug in the stuff that I know. What y value do you want to start with? 2 is fine. So if I start with 2 on the top, that means I got to start with 5 on the bottom. Have to do that. Okay. So what goes on the top? 2 minus what? -6. And on the bottom, that leaves only 5 minus 10. That'd be 8 over -5. -8/5. And I just put the minus sign either with the top number or out to the front. I usually don't leave it with the bottom number when I'm talking about my slope. I usually stick it to the top number just so that I don't mess up if it's a negative slope. Again, remember, you want to reduce your fraction if it will. I know neither of these did reduce, but you always want to reduce fractions as far as that they can. Let's do 5 -3 and 2 -3. Okay. So again, set it up with the slope formula. What do we end up with on the top here? -3 minus -3 ends up being what? 0. And then 0 divided by anything is 0. What kind of line has a 0 slope? Is it vertical or horizontal? Horizontal, good. Yeah, horizontal lines have 0 slope. Okay, so we know that's what that would look like. And that's going to be important when we go to the next section and we're building equations. That if it's got a 0 slope, it's a horizontal line, so that means it's y equals a number, and in this case, it'd be y equals -3. But big thing there is it a horizontal or vertical line? That's big. Okay, all right. 2, 7, and 2, -4. What do we end up with on this one? Yeah, -11 over 0 or +11 over 0, depending on which way you put your numbers in there. But it's a 0 in the bottom. What's the problem with that? Can we ever divide by 0? No, that's an undefined operation. So that means that this is an undefined slope. What kind of line has an undefined slope? Vertical lines have undefined slope. It's a vertical line, it's got an undefined slope. Remember, a horizontal line is 0 slope. Vertical lines are undefined slope. So that's the difference in those two. So this one would be an x equals a number, and it would be x equals 2 in this case when we start building those equations out of that. All right, so undefined slope there, 0. The way I've remembered this since maybe I was in 8th grade and we did this the first time. I had a high school or a math teacher pretty much through all my high school, because I went to a small high school. She said if it's 0 under the line, it's undefined, and that rhymed and it made it stick in my head. 0 under the line is undefined. That's how I remembered that, and the way I've remembered it since I was a kid. So, all right. Does anybody need to take a bathroom break or anything? We got one more section left. It's not a short section. It's not an incredibly long section, but it's not a short section. Does anybody need to take a little break? Or are you guys good? Just roll? Yeah. You guys okay with that? All right, let's roll. Let's do it then. All right. Last section of the day, section 2.5. And I'm not going to graph anything in this section. We're just going to build some equations. So we're going to build equations of lines. All right. And we're going to deal with first point slope form. I'm going to work on writing some things in point slope form. We will get back to slope intercept form very shortly. Okay. But point slope form is a form that you may or may not have used in a math class before, depending on when and where you went to school at. I tend to use this a lot right now where I'm teaching, but it's not something that maybe 5 years ago I used very much. So depending on, that sort of thing. So point slope form looks like this. Y minus y1 equals m parentheses x minus x1. All right, so I'm going to point some things out here. That this y1 and this x1 are from an ordered pair. Okay, that M is still the slope. It's the same slope we've been dealing with in the last section. That's that y2 minus y1 over x2 minus x1. Okay, this y and this x here are still the same y and x from slope-intercept form that we did in the last section. Okay, so three things that are numbers in here: the slope, the x1, and the y1. That's what makes up point slope form. So what we're going to do is we're going to build some equations in point slope form, and then eventually we're going to take that point slope form and put it in slope intercept form, and then we'll do another form called standard form. So we're going to do a lot of stuff but point slope form is really where it starts out of that. So that's what we're going to do first. Okay, so we're going to write the equation in point slope form. All right, so the first example is we're going to write the equation in point slope form for a line that goes through -4, +1 with a slope of -3. So on this one, they give us a slope and they give us the point that the line goes through. So they give us everything we need to write the equation in point slope form. Okay, so we're going to take point slope form and we're going to replace the things where they belong. So I'm going to use some highlighting here to help us know where stuff belongs. Okay, that makes some sense where things are going to go. We're just going to plug them in there and then simplify a little if possible. Okay, so the y minus -4, or excuse me, y minus 1 equals -3, and then x minus -4. Technically, that's point slope form, but there is a little bit of simplifying that we could do there, and that's where these double negatives happen. Double negative is going to turn it into what? Positive. So that's how I'm going to write my answer. Y minus 1 equals -3, x plus 4. And that's the final answer for point slope form. And that's what you're going to see on quizzes and on the labs is they want you to go ahead and simplify that double negative to a plus. And I do too. Because you would do that anyway when we get ready to do the other stuff. Okay. So here we were given a point and given the slope already to us. So really, really easy problem when they do that. Just plug it in where it belongs. Gets a little bit more difficult when they do this. They say, okay, write the equation line in point slope form that goes through -3, +2, and 2, -4. What did they not give us? A slope. And if they don't give us a slope, point slope form is hard to do because we don't have a slope. But we do have two ordered pairs, and we know how to find the slope between those two ordered pairs. So we want to first find the slope. That'll be -4 minus 2 over 2 minus -3. Should be -6 over 5. So there's our slope. And then we would write that in point slope form. And this is where you've got to, pick a point to use. All right. So if you used negative 3, 2, your point slope form would be y minus 2 equals negative 6 over 5 x minus negative 3. And you would simplify that to be y minus 2 equals negative 6 over 5 x plus 3. But that's not the only correct answer. You could have used the other ordered pair. If you're using 2, negative 4, then it's y minus negative 4 equals negative 6 over 5 x minus 2. And you simplify that to be y plus 4 equals negative 6 over 5 x minus 2. On the exam, it'll tell you which one of the ordered pairs to use. So it's not a guessing game there. Or it will have, some obvious errors in the answer choices, that the slope's wrong or something like that, or signs are wrong. So you've got to keep in mind how to get it with either ordered pair there. But that's point slope form with those. Okay. Now, the next thing we want to talk about is putting them in slope intercept form out of that. And slope intercept form is y equals mx plus b. So slope intercept form. There's a hyphen between that, so I usually write that. Slope intercept form, again, y equals mx plus b. We've already talked about this form in the last section. Okay, so what I try to do with this is I start with point slope form and then go to slope intercept form. And then I'm going to use slope intercept form to go to standard form later on. Is how that's going to work. So we're going to write that in an equation of a line in slope intercept form that goes through 0, 6 with slope of negative 2. Okay. So what I'm going to do is I'm going to start with point slope form. Which would be y minus 6 is equal to negative 2 times x minus 0. And then to be in slope intercept form, what do you get by itself? What did we get by itself in the last section? We were trying to graph those lines. So if we've got point slope form, all we got to do is get y by itself out of this form, get this y over here by itself, and we'll have it in slope intercept form. Okay. So what would be the first step to getting y by itself on this equation? Can't do that. Remember order of operations?
Oh, okay. So you have to
yeah, I need to distribute first because I got that parenthesis there. So I've got to distribute this negative 2. And that's going to give me negative 2x. Technically plus what? Negative 2 times 0 is 0. So there's actually plus 0 out there. I'm not going to write it because plus 0 doesn't help us any. But then we have y minus 6 over here. Now I can add 6. But does it go to the 2x?
No.
Yeah, it adds to that 0 that's over there, technically. So there we have negative 2x plus 6. And there's our slope intercept form that we wanted. So there we are in slope intercept form. And I'll abbreviate that slope INT. And that's the form that they want us to stop at here. Okay. And the D, let's say they want us to go through negative 4, 1 with slope of negative 3. This is actually example A again. but we're going to slope-intercept form this time. Okay. So again, I'm going to start with point-slope form, and I'm going to abbreviate even further, PS, for point-slope. Y minus 1 equals -3. X minus -4 turns into +4. Remember. So by the end of this section, we should be really good at point-slope form because we're using it every time. Okay. And then get y by itself, and we'll get in slope-intercept form. So what's the first step to getting y by itself? Distributive property, -3x minus 12. So it's 2 steps, really, to every problem to get y by itself. Just add 1. So there's y is equal to -3x minus 11. And there you are in slope-intercept form. Okay. Not too bad. Pretty easy. Again, that point-slope form is the key to it all. Through -3, 2, and 2, -4. So they're giving us 2 ordered pairs, and they want us to find the slope-intercept form of that line. Okay. So what's the first thing that I need to find? The slope. Good. So y2 minus y1. So I'm going to say -4 minus 2 over 2 minus -3. That'd be -6 over 5. And then the good thing about going to slope-intercept form is the fact that it doesn't matter which ordered pair I pick. I'm going to pick the one that I think is the easiest to do and work with it to get from point-slope form to start off with. I'm just going to pick that first one. So I'm going to use the point-slope form. Y minus 2 equals -6 over 5 times x plus 3. So that's using the first ordered pair to get into slope or point-slope form. There is a fraction for the slope, and that's just part of it. It's going to happen pretty regular. And then I'm saying, okay, well, what's the first step that I do to get it into slope-intercept form? Distributive property again. So that's going to be -6 over 5x minus 18 over 5. And if you're uncomfortable with fractions and multiplying them, that's okay. You know, -6 over 5 times 3. And then I hit math, enter to get there. -18 over 5. That's what I'm doing there. And then I still have the y minus 2. One more step gets y by itself, and that's what I'm after here, is to get y by itself. What do I do? Yeah. -6 over 5x. And then I need to know what's -18 over 5 plus 2. And then again, I'm going to swap it to a fraction. -8 over 5. And there I am in slope-intercept form. The great thing about this is no matter which ordered pair you started with for your point-slope form, your slope-intercept form should be exactly the same. Okay? That it ends up being the slope-intercept form being the same no matter which ordered pair you use for point slope form. Okay? It doesn't matter. That will always be the case. Okay. All right. Let's get our last form that we're going to deal with here. And that's standard form. And standard form is really easy to get to from slope-intercept form. Okay, it's not so much that it's actually usually either 1 or 2 steps away, just like from point slope form was to standard form. All right, or from point slope form to slope-intercept form was 1 or 2 steps. Standard form is going to be 1 or 2 steps away from slope-intercept form. Standard form looks like this. Capital A, X, plus capital B, Y, equals capital C. A, B, and C are integers. Biggest thing is they're not fractions. When we finish a standard form problem, it will not be in fraction form. Okay? There will be no fractions left in it. We will fix it if there are any fractions in it, and I'll show you how to do that. Really, really an easy thing. Okay? Now, so when you're looking at a standard or a slope-intercept problem, let's what was the last one? So this is example F. We want to put y equals negative 3x minus 7 in standard form. And I'm going to show you how to get from slope-intercept form to standard form. Because that equation right there is in slope-intercept form. We can see that. It's got y by itself, got a slope and a y-intercept. Okay? To get that in standard form, you got to have x and y on the same side. So how do I move this x over there? Yeah, that's right. Add 3x. Cancels. 3x plus y equals negative 7. Guess what? That's standard form. You're done. Okay? So if you can get an equation in slope-intercept form, you can get it in standard form in 1 step. If there are no fractions. If there are fractions, I'm going to show you what to do then. Okay? So just get x and y on the same side in order. X, then y equals a number. That's standard form. Okay? Make sure there are not any fractions. Also, make sure nobody can be divided by the same thing. Like you couldn't have, if it's in slope-intercept form, it won't be that anyway. But if for some reason maybe you're given something like 2y is equal to 6x plus 8, what do you know all 3 of those numbers are divisible by? 2. So you would divide everybody by 2 before you even start. Okay, so make sure you do that. It's just simplifying the problem. Okay, so that's one of the other little rules about standard form. That if you're starting from slope-intercept form, you won't ever encounter it. But if you're starting from something else, you might. Okay, let's look at one that's maybe got fractions in it. So we want to put y equals negative 6 over 5x minus 8 over 5 into standard form. Okay, so this was the answer to one of our problems, one of our examples earlier, example E. That was the answer to it, I believe. Make sure that's right. Example E. Yeah, look at there. That's that problem. That's where that came from. Okay, we want to put that in standard form. So remember, standard form puts x and y on the same side. So how do I get the 6 over 5x over there? Yeah, I'm just going to add it. Now cancel it out over here. So we get 6 over 5x plus y is equal to negative 8 over 5. But it's got fractions in it, and that's the problem. Okay? Well, the easy fix, and it is an easy fix to get rid of those fractions, is look at the denominator in those fractions. They're 5s, right? If I multiply every piece by 5, it's going to cancel that 5 in the bottom out. But I have to multiply every piece by 5. So to fix it, I multiply this by 5, I multiply that by 5, and I multiply that by 5. Because that would be the common denominator for the fractions. And we'll do one with different denominators in just a second. Okay, so on this one, 5 times 6 over 5 is 6x. 5 times y is 5y. 5 times negative 8 over 5 is just negative 8. If I'm unsure of that, 5 times 6 over 5, 6, and then negative 8 over 5 times 5 is negative 8. That's where I'm getting that stuff. Just multiplying those two together. Okay, and there we have standard form now, no fractions. Where it can get a little bit more difficult maybe would be if you want to put y equals 2/3 x plus 3/4, or let's do 1/4. 3/4 is okay. Let's do 3/4 into standard form. That way we'll get some things happening. Okay. If we're going to put that in standard form, we're still going to subtract the 2/3 x. That's negative 2/3 x plus y is equal to 3/4. But now when we try to get rid of our fractions, the denominators are not the same number. So we've got to think, okay, what number would get rid of a 3 but would also get rid of a 4? 12. That's a number that 3 and 4 both go into. So I'm going to multiply everybody by 12. That's how you do that. Be negative 8x, 12y, 9, I think. That's right. 3/4 of 12 is 9, yeah. 2/3 of 12 would be negative 8, yeah. And then 12y, yeah. And that would be our standard form for that. All right. All right, let's look at doing the whole thing. We want to write the equation in all three forms that goes through 1, 1, and 2, 4. So if we're going to write it in all three forms, we're going to do a point slope form. We're going to do a slope intercept form. And then we're going to end up in standard form last. But before I can do any of those, what do I have to have? I got two x's and y's. So I got to find the what? Is that it again? Slope. That's exactly right. Got to find the slope first. Okay? Because the whole, getting point slope form, if I don't have a slope, I can't do anything. So 4 minus 1, 2 minus 1. Be 3 over 1, which is just 3. That's great. Slope's a nice number 3. Which ordered pair do you want to use for point slope form? Does it matter? No. Pick one of them. Be careful not to mix and match and use one piece from one and one piece from another. That's a pretty common mistake in this. So I'm going to pick the 1, 1 because ones look easy, right? Y minus 1 is 3, x minus 1. Next thing, that's point slope form. That's that form. It's already done. I don't have to even simplify that. Slope intercept form, I'm going to take that form, distribute, and then get y by itself. 3x minus 2. That wasn't too bad. Now to get in standard form, what do? Subtract 3x. And there I am in standard form. So I got all three forms without just a ton of work, but being able to get any of those forms. Your exam's going to ask you usually for one of those. And if it's slope intercept form, stop there. If it asks for point slope form, you don't have to do anything else. If it asks for standard form, though, that's the best, most logical way to get there is start with point slope form and go down to standard form. That is the best way to get there. Okay. Stick with me. Got 2 more examples and we're done. Okay. 2 more things that we got to cover and we're done. All right. Very, very similar thing. Just talking about parallel lines next. Okay. Parallel lines. What do y'all know about parallel lines? They run side by side. Absolutely. They never what? Never cross. Another word for cross would be intersect. That's a the math word for that. They're never going to cross. They're never going to intersect. They run side by side. The biggest thing that we've got with parallel lines and what we're doing right now is that they have the same slope. That's the thing we need. The same slope. Okay. Big star by that. Flags. Not red flags, but green flag. Big green flag. Slopes are the same. That's big. Okay. Because that means we know where to get our slope if we're trying to build parallel lines. Okay. So if we're building parallel lines, we're going to do the same things that we've just done. If we're going, we want a line that goes through 3, 5 parallel to 2x plus 5y equals 4. Okay, so what they're asking us to do is take this equation, 2x plus 5y equals 4, and make a new line, or equation of that line, that goes through 3, 5. Okay, so what do I need out of that equation, the 2x plus 5y equals 4? I need the slope. The problem is that line is